A single missing hyphen sent an $80 million spacecraft into the wrong orbit and lost it forever. Not a logic error. Not a hardware failure. A punctuation mark that never made it from a notebook into the code. This is the story of Mariner 1, and it's one of the most expensive typos in human history. But the real lesson isn't about NASA. It's about something that quietly breaks software every single day. July 22, 1962. Cape Canaveral. Mariner 1 sits on top of an Atlas Agena rocket, ready to become the first American spacecraft to visit another planet. Its target was Venus. For decades humanity had stared at Venus, a glowing dot wrapped in cloud. Mariner 1 was supposed to fly past it and send back real data. It was a milestone moment for the space race. The rocket lifted off cleanly. For the first few minutes, everything looked perfect. Then, about 290 seconds into the flight, something went wrong. The rocket began to veer. It pitched and yawed in ways no one had commanded. Instead of climbing into a safe trajectory, it was steering itself toward danger. The guidance system, the brain meant to keep it on course, had started feeding garbage commands. The vehicle was now heading on a path that could send it crashing back down, possibly toward shipping lanes or land. The range safety officer had seconds to decide. With the rocket off course and climbing, he made the only call he could. He hit the destruct command. 293 seconds after launch, Mariner 1 was blown apart over the Atlantic. The mission was over before it even reached orbit. So what actually happened? At first, no one knew. The investigation pulled apart every system, the rocket, the antennas, the radar, the software. And eventually they found it. The guidance worked like this. Radar on the ground tracked the rocket and fed its speed and position into a computer. The computer ran equations to smooth that data and send back steering corrections. To smooth out small jitters in the radar signal, the equations used an averaging step. One variable represented the rocket's velocity, and that value was supposed to be smoothed over time, not used raw. In the original handwritten math, that smoothing was written as a symbol over the variable. A bar. An overbar, drawn across the top of the letter, meaning take the smoothed, averaged value. Here's where the disaster begins. That overbar wasn't a number or a letter. It was a notation, a piece of human shorthand that lived in the heads of mathematicians and on paper. When the equations were handed off to be transcribed into the actual guidance code, that little bar over the symbol got lost. Dropped. Never written down in the program. NASA later described it as a missing overbar, often retold as a missing hyphen. Either way, one tiny mark that meant smooth this value simply vanished in translation. Without the smoothing, the computer no longer averaged the velocity. It reacted to every tiny fluctuation in the radar signal as if it were real. Normal noise became false emergencies. So when the radar lost a clean lock for a moment, the computer saw the rocket lurching wildly, and it sent violent corrections to fix a problem that didn't exist. The cure was the catastrophe. Think about that. The physics were right. The engineering was right. The code did exactly what it was told. The failure happened in the gap between a human's intent and the machine's instructions. Arthur C. Clarke called it the most expensive hyphen in history. But the size of the price tag isn't really the point. The point is how invisible the failure was. Every line of that code could pass review. Every function could look correct. Because the bug wasn't in the logic. It was in what got left out when a human idea became a written symbol, became a typed instruction. And this is the part that should make every developer uncomfortable. We still do this. Constantly. Every requirement, every spec, every ticket is a translation from human meaning into machine instructions. A product manager says the price should round up. The engineer hears round to nearest. Nobody's lying. Nobody's incompetent. The meaning just leaks out somewhere between the conversation and the commit. That's why off-by-one errors, dropped edge cases, and misread specs cause more outages than exotic algorithm bugs. The hard part of software was never the code. It's getting human intent across a chain of fragile translations. And notation makes it worse. A symbol that means something obvious to the person who wrote it can be meaningless, or worse, ambiguous, to the next person down the line. Context doesn't survive the handoff. This is exactly why modern engineering leans so hard on things that close the gap. Automated tests that capture intent. Code that's written to be read. Pairing, reviews, and asking the dumb question out loud before you build the wrong thing. Because the most dangerous bugs aren't the ones that look scary. They're the ones that look completely fine to everyone, until a rocket veers off course and someone has to hit destruct. Mariner 1 failed, but the lesson didn't. Just 5 weeks later, Mariner 2 launched and became the first spacecraft to successfully reach another planet. They fixed the process, not just the symbol. So the next time you read a vague ticket, or write a clever symbol only you understand, remember the overbar that never made it into the code. The gap between what we mean and what we say is where the real bugs live.